All right, folks, in this lesson, what we're going to learn about is called polar coordinates, okay? Now, polar coordinates are really neat, at least I think they are, and I think the best way that you can understand polar coordinates is if we compare it to the coordinates that you are already familiar with. See, what you know how to do, so like let's say you have a coordinate plane, and you plot a point 1, 2, 3, 4, and up 1, 2, right? You learned this a long time ago in math class that if you plot that point right there, here's the x-axis and here's the y-axis, that you would have given that point the coordinates 4, 2, right? So this is the point 4, 2, okay? These coordinates that you have been using for the last probably 5 or 6 years of your math life, okay? These are called rectangular coordinates, okay? Rectangular coordinates. Now, what makes them rectangular is the fact that there is a horizontal distance, like a base, and then a vertical distance, like a height. And from that point, if you go all the way back to the origin, you actually can create a rectangle, right? So rectangular coordinates are always given in x, y, okay? Well, polar coordinates are a little different. Polar coordinates, in fact, we can keep that point right here. Every point on the coordinate plane, or every point, let's just say every point from an origin point, we call this 0, 0, right? X is 0, y is 0. And the polar coordinates still use the x-axis and the y-axis, but we don't necessarily call them the x and the y-axis. We have a horizontal axis and a vertical axis, and there is a starting point which is still 0, 0, but it's 0, 0 for a different reason, okay? And so this point right here can also be given in what are called polar coordinates. So when you're trying to identify a point, a distance away from a starting point, you can do it using rectangular coordinates, or you can do it using polar coordinates. Now, polar coordinates are still two numbers in parentheses with a comma between them, but instead of being x, y, they are r, theta, okay? And what the r represents is a radius, okay? R is radius, or you can just call it distance, okay? So the r represents the distance away from the starting point right here, okay? So what you would put here for r would be whatever the distance is between this point and this point right here. Whatever that distance is would be the r, or radius, okay? Now, how is that different from rectangular coordinates? Well, rectangular coordinates are identified by two distances, a horizontal distance and a vertical distance, right? That's a rectangular coordinate. But polar coordinates are determined by a single distance, a straight line distance from the starting point to the point right there. We call that the r, or the radius, okay? All right, so then what is the theta? Well, the theta is actually what we've been working with for the past several weeks. Theta is the angle measure from the initial side. Now, we have been understanding, initial side. We have been using, and will continue to use, the positive side of the x-axis as the initial side. And so this angle measure right here, from here up to this line, so we have this radius that goes from the origin out to the point, and then that line segment, which has a distance, or r, also has an elevation up from the x-axis, which is theta. And so what we're doing is we're identifying a point by its elevation from the positive side of the x-axis, or the initial side, its angle measure from the initial side, and then its distance from the center, okay? And so what we originally had here was the point 2, 4, and later in this lesson, I'm going to show you how to convert this 2, 4 into polar coordinates, okay? But right now what I want to do is I want to show you a couple more examples of how we can identify or how we can understand polar coordinates. All right, so what we have here is a regular coordinate plane, a grid, and this is what we generally use to identify rectangular coordinates, right? We have the x-axis here, we have the y-axis here, and like I said before, we had identified the point 1, 2, 3, 4, 1, 2. This is the point 4, 2, right? In rectangular coordinates, okay? Well, there's actually another kind of plane that you can use to understand rectangular coordinates, okay? And so what I'm going to do is I'm going to switch here, and I'm going to try and explain it to you. This is what we call or can call a polar coordinate. It's not a grid, but it's a polar coordinate plane. And let me show you some of the qualities of it. Let me show you what you're looking at here, okay? You can see here we have our, the ones that we already understand. We've got pi over 6, pi over 4, and pi over 3. But I want y'all to also notice here that we have pi over 12 and we have 5 pi over 12. See, we have pi from here around to here. We haven't done this previously, broken up into 12 slices. 1 slice, 2 slices, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? And so we can we use these lines that are radiating out from the center to identify the angle measure, okay? And so we would go from the initial side right here, okay? And let's say that we were concerned with a point that is over here. Let's say the point was right here. Let's say we want to identify the polar coordinates of that point right there. Well, one of the things we would want to do is we would want to, well, we don't have to draw the line, but let me go ahead and draw a line here. And we would want to know, in order to put it in polar coordinates, remember, r comma theta. So the first thing we would want to know is we're going to do theta first, okay, because that's what we're talking about right now, and then I'll explain r, okay? So we would want to know what is this theta angle measure right here, starting at the initial side and going around to where this terminal side that goes out to the point, okay? Well, if we go along here, we can see that this is 11 pi over 12. It's hard for you to see, but this is 11 pi over 12, okay? Here's 5 pi over 6, which you already know, 3 pi over 4, 2 pi over 3. You're already familiar with all of these points. So in a way, what you're looking at here is like a unit circle, okay? And therefore, the theta angle here is going to be 11 pi over 12. Okay, so this theta angle is 11 pi over 12, okay? And so in the polar coordinate, we would put in the place of theta 11 pi over 12, okay? Now we would need the radius. Well, watch this. Do you see these lines? Here, I'm going to erase some of this right now. Do you see these lines, or these circles that are going out from the center? Well, each one of those represents a distance of 1, okay? So the distance from here, which is a distance of 0, here's a distance of 1, a distance of 2, 3, 1, 2, 3. This is a distance of 4, a distance of 5, and a distance of 6, right? Well, that's easy to do on a horizontal line or even on a vertical line. 1, 2, 3, 4, 5, 6, right? But on a diagonal line, it's harder to determine distance. Well, because we have these circles drawn in, we can identify that the distance along this line is 1, 2, 3, 4, 5. So this point right here has a distance or a radius of 5. And we say radius because we're referring to the distance from the center of a circle out to this circle right here. Okay, that circle has a radius of 5. Therefore, this point right here is given by the polar coordinates 5, and angle measure of 11 pi over 12. And so these are the polar coordinates of this point right here, okay? All right, let's do a couple other examples where I'll try and allow you to try and figure out what are the polar coordinates of a certain point. Eventually, we're going to come back to this 4-2 in just a couple minutes, but for now, I want you to practice using this polar coordinate plane to try and identify some polar coordinates. All right, so here's what I've done. I've gone ahead and, because it's hard for you to read, I've put in the theta angles that you don't normally know. We know that you know 0 and 2 pi here, and that up here you know pi over 6, pi over 4, pi over 3, 2 pi over 3, 3 pi over 4, 5 pi over 6, 7 pi over 6, etc., all the way around. But I've gone ahead and drawn in pi over 12, 5 pi over 12, 7 pi over 12, 11 pi over 12, 13 pi over 12, 17 pi over 12, 19 pi over 12, and 23 pi over 12, okay? And then the radii, I don't know how well you can see the circles, but this first circle is a radius of 1, the second one is a radius of 2, radius of 3, 4, 5, 6, 7, okay? And here's what I'd like you to do. I'd like you to start out identifying the polar coordinates of this red dot right here, okay? Why don't you pause the video, take a second, and see if you can figure it out. All right, so we need the radius and we need the theta angle, okay? Well, it's on the second circle heading out, so from here, we go a distance of 1, distance of 2. So this has a radius of 2, okay? So we'll put 2, comma, and then the theta angle from here around to here, the theta angle that this is on is 2 pi over 3, okay? So 2 pi over 3. Therefore, this red dot is at the coordinates 2 and 2 pi over 3, right? Okay? All right, let's try this orange one right here. And why don't you pause the video and see if you can figure out the polar coordinates of that orange point. All right, so first we need the radius. Well, going out from the center, we're going to go to the first circle. That's 1 circle, 2 circles, 3 circles to the 4th circle. They're called concentric circles. So this is the 4th one coming out. So that's a radius of 4. And so this point has a radius of 4. And then what is the theta angle measure? Okay, well, it's going to start here, and it's going to come around to right here, okay, along this line right here, which is at 7 pi over 6. So this is the point 4 and 7 pi over 6. Now, I want you to notice something interesting about this point right here. This point is in the 3rd quadrant. First quadrant, 2nd quadrant, 3rd quadrant. So as a rectangular coordinate, it should be a negative x and a negative y, correct? Negative x, negative y. But notice that in polar coordinates, that the coordinates are actually positive and positive. Generally speaking, in most cases, your polar coordinates are going to be positive, positive. In fact, this is a good time to mention something. You're going to want to write this down, is that theta in polar coordinates, theta always falls between 0 radians and 2 pi radians. You can also, by the way, you can also do polar coordinates in degrees. So you could make this 2 pi over 3, okay? You could do that as 120 degrees instead of 2 pi over 3. So you could also write this coordinate as radius of 2, theta angle of 120 degrees. These two are exactly the same. They are the same polar coordinate. It just depends on whether you're doing your polar coordinates in radians or in degrees. In this class, we're going to do our polar coordinates in radians, okay? But you could find yourself in another class someday, another math class, where you do polar coordinates in degrees, okay? All right, when it's in degrees, theta is always going to fall between 0 and 360 degrees. Here's what I'm saying, is that you're never, ever going to use angle measures on that are coterminal angle measures, okay? You're always going to use the angle measures that we're familiar with off of the original, radians falling on the unit circle on the first rotation around. Now, understand that you could wind up doing your theta angle in that doesn't include pi. It could be a decimal value of a radian, so to be approximately equal to 6.28. So you're never going to have radians that are smaller than 0, and you're never going to have radians that are larger than 6.28. If you do, you need to convert them by either subtracting 2 pi or adding 2 pi. Okay? All right, so our angle measure is never going to be negative, and generally speaking, your radius is always going to be positive. Now, there are funky ways of writing these things where you could represent the radius as -4 and use the angle opposite going the other direction. So you could actually write this, and I don't want to, this is just sort of extra material. Don't worry about this too much, but if you're interested, you could actually write this polar coordinate as -4 and pi over 6. That's where you do the angle of pi over 6, but instead of going +4 in that direction, you actually go -4 in the opposite direction. So these two angles right here, where you have a -4 radius and a theta angle of pi over 6, are actually the same point on the polar plane. Okay? But we're not going to do that in this class. I just wanted to give you that as a little aside. Okay? All right, now let's do, how about this green point down here? Can you try identifying the polar coordinates of this green point? Pause the video and give it a shot. All right, so first we need a radius. Well, we're going all the way out to the last edge that we have in this particular figure. So we're going to a radius of 1, radius of 2, radius of 3, 4, 5, 6, 7. So this is a radius of 7, comma. And then the theta angle, remember, we're not going backwards. We're not going this direction. This is not our theta angle this direction. Our theta angle has to start here and it has to go all the way around to here, which is 7 pi over 4. And so the polar coordinates for this point are 7 and 7 pi over 4. Now this last one here, you want to try this purple one that's really close here. It's along this line right here. It's along that line, and it's on the first circle. Okay, so pause the video and see if you can write down the polar coordinates. All right, so we can see that it's on the very first circle coming out, so that means the radius is 1. So this one has a radius of 1, comma, and the angle measure, it goes from, the theta angle goes from here up to this line right here. This is the terminal side, and therefore that's 5 pi over 12. So this is 1 and 5 pi over 12, and these are the polar coordinates for this point right here. All right, so what I want to do now is I want to sort of mess with your head a little bit, and we're going to switch now back. We're going to switch back to the rectangular coordinate grid and see what this is going to look like. All right, so now that we've switched back, you can see something kind of interesting and a little weird here, right? You can see that we could actually identify rectangular coordinates of all these points, right? Like this one right here, the 2 and 2 pi over 3 looks like it's at the point -1 and maybe positive 1.75 or something like that. Now, there is a more precise value for it. We're just generalizing here. And I'm going to teach you how to identify the exact values of rectangular coordinates given polar coordinates. Okay, but I wanted to show you that every single point given an x-axis and a y-axis and a starting point, an origin, can be represented using either polar coordinates or represented using rectangular coordinates. Okay, and so one way to help you understand that, and I'm going to go ahead and erase these points. I'm going to leave. We'll come back to the 4, 2. Let me erase it. It's just going to be harder to see if I don't erase it. Okay. What I want to do here is I actually want to put both of them on top of each other. I want to show you one more picture where we have the polar plane here and the rectangular coordinate plane. Okay. And so you can see that we still have the x-axis and the y-axis, but with both of them on top of each other, you can see how we can go out along the radii, right? And you can also see, let me go back a second, we noted earlier that this is a radius of 1, right? This is a radius of 2, this is a radius of 3, this is a radius of 4, a radius of 5, radius of 6. We could also do the same thing on the y-axis. That's a radius of 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. Now, if we go to the polar or to the rectangular coordinates, if we throw the rectangular coordinates in there, you can see that they're in the exact same places, same distances. This is a distance of 1, distance of 2, 3, 4, 5, 6 on the rectangular coordinate plane. 1, 2, 3, 4, 5, 6. Now, one of the big differences is this, is if we were to go into the negative direction here, this would still be a radius of 1, radius of 2, and radius of 3. But if we were in a rectangular coordinate, this would actually be -1, -2, and -3. But remember, in polar coordinates, we do not have negative distances, or at least not in this particular lesson, okay? All right, so now what we're going to do is we're going to move on from understanding what are polar coordinates, and we're now going to move on to converting from polar coordinates into rectangular coordinates.